multiply by the reciprocal, 2 pi over 12, that's good. Yeah, reduce the fraction pi over 6. Okay, so that's what you should get. This is just 4/15, and this is pi over 6. Cool? How about number 3? What do we multiply by? Well, reciprocal of the denominator is x cubed, bless you, over x plus 1. Can I do anything here? Cancel the? Yeah, this becomes x squared with the x. Can I do anything more? X. Yeah, so you have factor in the difference of squares. Good eye. Yeah, good thinking ahead. So do you see the x squared minus 1? Do you all recognize that as the difference of squares? X, how does it factor? X minus 1, x plus 1, yeah. And then all over x plus 1, and now you can cancel your x plus 1s. So look out for things you can factor. And finally, you just have x squared times x minus 1. You can distribute or not, but that's fine. Okay? That's Thamir. Any questions for me? So today's topic is complex fractions. Are you ready? Ah, we're ready for complex fractions. We did this. Aw, they don't dislike you.
Yeah, they do.
You beg to differ. Okay.
Fractionize.
Fractionize. We are definitely fractionizing today. Okay. That was just commutation. We already talked about that. Okay. So whenever you guys have something like this, oh, I forgot to ask. Is there anything you guys want me to talk about from the homework? Yeah. 7? Okay. I can do that. B and C. Domain range. Okay. So 7 looks a little like this. It has an asymptote at 1. A horizontal asymptote at 1. And then it has vertical asymptotes at -2 and 2. Okay. Hey, we're talking about 7 in the homework. Were you guys confused on domain and range at all? So, yeah, let's talk about that. So we're going to talk about domain and range. Domain of f of x. So the domain here is, we have the function. I should write the function in. It looks like this. And then you got something at 0, like a little parabola in here, and then hyperbolas on the sides. So the domain of the function, if you draw like a vertical line for domain, this goes out to infinity, right? Negative infinity. So you would say negative infinity all the way to, do I have a value at -2? No, there's an asymptote. So you have to stop it at -2. So you would say, okay, negative infinity to -2, union. Do I have a value immediately after -2? Yeah, that goes all the way down, right? So you would say, okay, pick up not including -2, but all the way to what value? 2, right? And then union, what's the last interval? Does it pick up right after 2? Yeah, so 2 all the way to? Infinity. You got it. Okay? Range is, I do this, I do horizontal. So do I have negative infinity? Is that good?
Yeah.
Yep, all the way to, stop me when you need me to stop. 1, right? Because that's no value, horizontal asymptote. And then 1 all the way to infinity. Okay, so negative infinity to 1, union 1 to infinity. Does that help? Okay. Do you guys remember how last year I taught you, if I gave you something like this, like with multiple fractions, how to get rid of it in one step? Do you guys remember how we do that? What? Yeah? So we multiply each, here's your fill in the blank. Multiply the numerator and denominator by each complex denominator. So we multiply this, what are my complex denominators here? BDFH, any like fraction within a fraction, right? So we multiply by BDFH over BDFH. Can you guys help me out with what this turns into when you distribute it. When you distribute it to the a over b, what's left? Chop off the b's, you're left with a dfh, yep, plus the d's cancel, so you're left with cbfh, right? Is everybody good with those two?
Where do we get the BDFH, sorry?
Yep, nope, so that's the complex denominator. Those are all your complex denominators.
Oh, okay.
So we multiply by every complex denominator to get rid of it.
Oh,
Yeah,
okay,
yep, that's okay, no, glad you asked. Distribute, e over f, the f's cancel and you're left with e, b, d, h. And you distribute here, what are you left with in the last one? G, b, d, h. G, b, d, careful, h cancels, so G, b, d, f, yeah. Music, G, b, d, f. Good place to find noise. Okay, that's it, right? So that was a refresher from what we did last year. Okay, are you ready? Let's do some complex fractions. Given f of x is that nasty thing and g of x is that nasty thing, find, what is that asking you? Can somebody read this for me? What is it? F over g of x, f divided by g of x. What does that mean? I want you to find f of x divided by g of x. That's what that means, right? You gotta get used to that notation. So then we divide them. Here we go. 1 over x plus 1 minus 1 all over 2 over x plus 1 plus 1 over x. Okay, what do I have to multiply by? In other words, what are my complex denominators here? X and x plus 1. There's 2x plus 1s, but multiplying by one of them will take care of it all, okay? So I multiply by x times x plus 1 all over x times x plus 1. Then I distribute. So when I distribute to the 1 over x, what's left? 1 and, so the x plus 1's cancel, 1 and x, right? Does that make sense? So your x plus 1's cancel, you're left with x. When I distribute it to the minus 1, it's just minus x times x plus 1, okay? All over, distribute, okay? When I distribute it here, what's left? X plus 1's cancel, you're left with 2x. And then when I distribute here, what's left in that term? X's cancel, so we're left with, yeah. You guys feeling okay with this? Good. So then can we cancel these x plus 1s over addition and subtraction? No, right? Okay, so instead we simplify the numerator, right? Distribute that negative x. You get x minus x squared minus 1 all over 2x plus x in the denominator is 3x plus 1. Oh, I'm sorry, did you see what I missed? When I distributed my negative x, that should be a negative x, right? Sorry about that. Fix it, minus x. So minus x squared minus x. Okay, now numerator, x and negative x cancel, and your final answer is negative x squared over 3x plus 1, done. Okay. Want to try one? Whew. Yes, right. That's the right sound effect for today. Okay. Go ahead and try the your turn problem. See how you do.
And then I can come around if you need help.
So if you need to see the first step, we're plugging in g of x for every x. So we get f of g of x, right, it goes inside of f. 1 over x minus 2 for that x, minus the 1. All over 1 over x minus 2 plus the 2. Does that help? Okay, continue. And if you have a question about that, I can help. Okay, let me just type this. I know you're probably still working, but I'm just gonna write the steps as we go. Times x minus 2 over x minus 2. Distribute. So you get 1 over x minus 2, the x minus 2's cancel, so you're left with 1. Be careful with this negative, okay? It's a negative 1 times the x minus 2, so that will need to distribute and make that a positive 2. All over, this becomes just 1 plus 2 times x minus 2. Can you cancel the x minus 2's? No, not over subtraction. Distribute. So you get 1 minus x plus 2, all over 1 plus 2x minus 4. The numerator simplifies to 3 minus x, and the denominator is 2x minus 3, and that should be your final answer. How are we doing? Do we have questions? Hey! Victory. Okay. As long as if you see what you did wrong, that's great. Okay. Ready to go to the next one? Okay, example 2. Let's spice it. Oh, I thought this was cute. I put this in. Team fraction versus team decimal. We're the ones you can trust to be rational. What's the use of being rational if you have no point? I feel like that's every debate ever. All right, anyway. Given f of x, is that fine? This mess. F of x minus f of negative 2 all over x plus 2, where x can equal negative 2. Okay, so take it one step at a time. You're asked to find this. I'm saying find f of x, so you should write f of x. Write exactly f of x. Minus f of negative 2. What do I need to do with that negative 2, guys?
Swap it for x.
Swap it for x. The negative 2, it's saying you plug in, wherever you see an x, you plug in a negative 2, right? So we get 1 over negative 2 minus 3. Does that make sense? That's f of negative 2. All over. Do I need to do anything with the x plus 2, or do I leave it as x plus 2? Leave it, because it's not f of anything, right? It's not telling you to plug it into the function, it's just plain old over x plus 2. Any questions yet? I see some, it looks like we have questions, but I'm not sure. Okay, keep going. So then, simplify. 1 over x minus 3 minus, okay, that's,
What?
what? Exactly, I don't know. Technology hates me today. Okay, 1 over x minus 3, that's better. Minus 1 over negative 5 becomes plus, right? Plus 1/5, so that's negative 5 plus 1/5. All over x plus 2. All right, now we gotta get rid of those complex fractions. What are my complex denominators that I multiply by? Yeah, x minus 3 and 5. So 5 times x minus 3 over 5 times x minus 3. There's sass in the back there. All right. Distribute. You get, what's left after I distribute it to 1 over x minus 3? 1 times 5 is 5, right? Yeah. No, because we have minus a 1 over negative 5, so minus minus becomes a plus. Thanks for checking. I can easily make a mistake. So we get 5 plus, now these 5's cancel when you distribute it to here. So the 5's cancel, you're left with x minus 3. I don't need parentheses because this is a plus. If it was a minus, you better use parentheses, okay? All over, the denominator is just 5 times x plus 2 times x minus 3. Can I cancel the x minus 3's? No, not over an addition. Just simplify the numerator as it is. You get 5 minus 3 is 2, so x plus 2 all over this. Can I cancel the x plus 2's? Yeah, right? It's all multiplication, there's nothing else added or subtracted to it. So your final answer here is 1 over 5 times x minus 3. And then you have to state the original x can't equal 2. What else can it equal right now? 3, yeah, because that makes the denominator 0. So you would just put comma 3. And this is, what? You can, you don't have to. It's kind of like whatever at that point, yeah. My main goal is for you to be able to,
Chill out.
yes, simplify it. All right. We're on the last problem. This is really it for today. You ready? Your turn problem. Go. All you.
It's just 50.
And then there's some like review, I think on this worksheet, there's some domain and range review for anything you were struggling with. Okay, you guys are rocking this. I'm gonna go ahead and, is it okay to write it up? Okay. So f of x, you just write f of x minus f of 1. 1 goes in for x. 1 minus 2 all over x minus 1. This becomes 1 over x minus 2. So this becomes 1 over negative 1. That's just what it simplifies to. And then minus minus becomes a plus. So plus 1 all over x minus 1. The only complex denominator we have is x minus 2. So we do that. You're left with distribute 1 plus the quantity x minus 2 divided by these two. And simplify the numerator. Don't cancel over addition subtraction. It's x minus 1 over x minus 1. Can I cancel x minus 1's now? Bingo, right? And you're left with 1 over x minus 2. What can x not equal? Original 1 or 2. That's what makes the denominator 0. Done.